Hello viewers, welcome back to class. I'm super excited to have you guys back to class again. You're welcome to Master Builders Online Academy. Don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell for more exciting videos. Guys, don't forget our policy here that you must not skip any part of this video. Ensure that you avoid every unnecessary distractions anytime you are set to watch and to learn new concepts from our platform. And finally, if there be any part in this video you do not understand, maybe when you watch it for the very first time, guys, you have the singular opportunity to replay the video over and over again until you understand it. And that's the reason why these lessons are coming in video format. So guys, let's get to work. On the board, we have second order differential equation, and not to forget, we are at the level where we are providing solutions to second order differential equation. And finally, we are equally at case 2, where f of x is not equal to 0. And under case 2, we have looked at the linear function, the constant functions. We have looked at linear functions. We have looked at quadratic functions. We have equally looked at the exponential functions. Now we are going to be looking at the fifth category, which is the trig function. I believe we are going to stop here. For any other question, you can document it at the comment section. Alright? Now we have the trig function, and this happens to be option E. Alright? Now, trigonometric functions. And for trigonometric functions, we have so many number of functions, but here we are limited to x, sine x, and cos x. Sine functions and cosine functions. Now, if f of x, in this case, f of x is equal to sine kx or cos kx, where k is the coefficient of x. It can be 4, it can be 5, it can be 3, it can be 1, it can be 10, it can be any number. And that k must be given alongside with the equation. So if you are not going to be obtaining the value of k, k must be given in the equation. But just understand that k here stands for the coefficient of the trig that you are given. Now, how do we now provide solution to any trigonometric identity or any trigonometrical function? Hey guys, the particular integral for trigonometrical functions is equivalent to y, and y is equal to c cos kx plus d sine kx. Of course, by now you shouldn't have issue with c and d, because we know that this is particular integral. And before you get particular integral, there exists a complementary function which already have constant a and constant b as the arbitrary constant. So from c, that is where you begin to have constants for the particular integral. So for this case, whether you are given sine kx or you are given cos kx, this is the particular integral that you use to obtain the particular integral for second order differential equation, where f of x at the right hand side is equal to trigonometry function. So guys, let's get to work. Now we have the very first question under this category, and it happens to be question number 9, being that this is a continuation class. So if you are visiting this page for the very first time, or you get to access our content on second order differential equation for the very first time, please guys, you have the singular opportunity to slide down to our playlist on our channel, where you can locate second order differential equation, and you will find numerous of lessons that we have looked at before this current lesson. Right? Now, we are asked to solve d square y over d square minus 5dy over dx plus 6y is equal to 2 sine 4x. 2 sine 4x. Now, sine 4x. This 4 we just have now is the k that you are given. So it does not change. It's only c and d that you will obtain. Now, when we look at this equation that we are given, like I do always, anytime you are dealing with second order differential equation, the very first thing you must not fail to look at is the right hand side of the equation to know whether it is equal to 0 or not. Now, if it is not equal to 0, you need to identify the type of function that is there. Are you there? And this is the reason why you need to go and study more about mathematical functions. Like I explained when we started from this lesson, right? We have more than 10 mathematical functions. Okay, now if this is understood, we know that at the right hand side of this equation, we do not have 0 there. The function exists and it is a true function. That is to say, this second order differential equation that we are given contains both complementary function and particular integral. Then on this ground, we need to define the future from the beginning because this will do us a really good. Understand that the general solution is given as y, then y would have become sum of complementary function plus the particular integral. And now, I don't expect you to have issue with obtaining complementary function, neither do I expect you to have issue with particular integral. The only difference between this particular integral and others that we have before is when we differentiate trig functions, there is a way the outcome turns out to, which is quite different from that of exponent, quadratic, linear, and others, right? This is the only difference. The same activities, the same process, the same steps you take. When you are doing others, the same step you are going to take here, no big deal. So now, how do we obtain the first part here, which is the complementary function? It's as simple as ABC. All we need to do is to replace 2 sine 4x by 0. Are you there? That's it. You need to equate the second order differential equation to 0 for you to be able to obtain the complementary function. This is the standard. And that's the reason why I often say, when you understand principles, you become a principal. And when you equally understand boundary conditions, you will not overstep your boundary. Very, very important. Now, at this point now, we quickly select to find the complementary function. Let the right hand side of our given equation be equal to 0. So automatically we are going to replace this guy with 0, and we have the equation as d squared y over the x squared minus 5dy over dx plus 6y is equal to 0. This is giving us equation 2. Alright? Now from here we can obtain equation 3. Now that we have successfully equated the given equation to 0, we know that we can deduce the auxiliary equation from equation 2. Understand that there is no way you can obtain the auxiliary equation when you have not first equated the second order differential equation you are given to be 0, or when the right hand side of the given equation is not yet 0. So you must ensure that it's 0 before you can obtain the equivalent auxiliary equation. Otherwise, you will have the roots all wrong. Now, at this point now, the auxiliary equation that is corresponding to this would have given us m squared minus 5m plus 6 is equal to 0. So we call this equation 3. Now, from equation 3, we can obtain the roots of the equation. Of course, we have 2 roots here, and we are going to be solving this question quadratically. And for quadratic equation, it's a matter of choice to use any of the 4 methods at your disposal. You can use the one you are good at. Okay? Now, also, don't forget that in this video, we majorly make use of factorization. Of course, by experience, I know that this is factorizable, right? Of course, I know that. Now, also, if you doubt it, then I have given you a method to test run when a particular equation is factorizable. So you can test run that. Now, from this point, we know that we are quickly going to multiply this guy by this guy. And the outcome would have given us 6m squared. So what are the factors of 6 that when we multiply it to give us 6, and when we add them up together, it will give us minus 5. Of course, I have explained this rule over time, that for the product of 2 factors to be positive, it is either the 2 factors are positive, or the 2 factors are negative. So if the 2 factors are positive, when we add them together, we have positive result. And if the 2 factors are negative, when we add them together, we have a negative result. And we are going to go with negative because the middle term here, which will controls the factors we are going to pick, is negative. So we are going to be using negative 2 and negative 3. Are you there? Negative 2 and negative 3. That will solve this problem. It's as simple as that. Negative 2 and negative 3. Okay? Now we have this as m squared minus 3 minus 2 plus 6 is equal to 0. Okay? It's as simple as this. Then the next we are quickly going to do here is This will have given us the first two terms and the last two terms. What is common between the first two terms, guys? What is common here is m. Open a bracket, m squared divided by m, we have m. Then this guy will have given us minus 3, minus 2, minus 3. Alright? Yeah. It's only two that is common between the last two terms. So when you factorize, you have the same factor or the same bracket you had originally. Then we quickly collect the multiplication factor where this will have given us minus 3 and m minus 2 equal to 0. And we understand that for the product of two factors to be 0 or two functions to be 0, one of the functions must be 0. Then we have m minus 3 is equal to 0 or m minus 2 is equal to 0. Therefore, finally, m is equal to 2 or 3. These are the two results that we have here. Now, if you understand that the results we just have now, they are real and different. So that means this is m1, this is m2. Then m1 is equal to 2 and m2 is equal to 3. So what do? We simply remember that y is equal to a exponent m1x plus b exponent m2x. Now we replace this with the complementary function, and we already know the values of m1, m2, and m3. Then this will have given us exponent 2x plus b exponent 3x. This is the complementary function. Now, for us to be able to obtain a particular integral, we have a lot of work to do here. Big work to do. Understand that to find the particular integral, P.I is equal to y, and y is equivalent to what? C cos kx. Now we understand that the k here is 4. So we have 4x plus d sine 4x. Now that we know y, understand that our interest now is to obtain the true value of c and d as usual. And for us to be able to do that, we need to differentiate this equation 2 consecutive times so that we can substitute into the given equation that will enable us to obtain the value of c and the value of d. If this is understood, all I need to do from here is dy over dx. Now understand that anytime you are differentiating trig function, please pay close attention. Although this is not differentiation, but I need to take my time to explain better. Okay? Anytime you are differentiating trig, the first thing you do is to take out the angle, and the angle here is 4x. When you differentiate 4x, you have 4. Put down the 4. Then d. When you differentiate cos, you have minus sine. Then the angle remains. The minus will have it. Then plus. When you differentiate 4x, you have 4d. And when you differentiate sine, you have cos. The angle remains. Then the second derivative, d squared y over the s squared is equal to. For the second derivative, all we simply need to do, same here, is when we differentiate this, the angle will also come out again. Are we there? We differentiate 4x, we have 4. 4 multiplied by 4, we have minus 16d. And when we differentiate sine, we have positive cos. So cos 4x. Now when we differentiate this 4x, we have 4. 4 multiplied by 4, we have 16. But when we differentiate cos theta or cos, we have negative sign. Then this sign will change. We also have negative 16d. Oh, the first one is c. First one is c. Okay. First one is c. Then sine 4x. This is it. Now at this point, all we need to do is to substitute these values we just obtained into equation, the given equation. Alright, we do not label it to be any equation, so we substitute into the given equation. So we replace this guy with this guy, we will replace the y by the square with this other one, and we will replace y with this. So we see that this is very, very complex. Now, what do? We replace this. And the value for that is minus 16c cos 4x minus 16d sine 4x. We are done with that. Then minus 5 multiplied by the one by the x is negative 4c sine 4x plus 4d cos 4x. Then for y, we now have plus 6 multiplied by y is c cos 4x plus d sine 4x, all is equal to. So when we check the right hand side of the equation, we find out that we have 2 sine 4x. This is very complex. So we want to see how we can shorten this so that we will be able to maximize this little space that we have here. All I need to do now is, I know that this guy, when this guy multiplies this guy, we will have plus 20. And when this guy multiplies this guy, we will have minus 20. And this guy multiplies. So all I need to do now is to collate all the signs. Then, or first, let's expand. When we expand this now, we have minus 16c cos 4x minus 16d sine 4x, then plus 20. Now when we multiply negative 4 by negative 5, we have plus 20c sine 4x, then negative 20 d cos 4x plus positive c cos 4x plus 6d sine 4x is equal to 2 sine 4x. It's as simple as this. So at this point now, I need to now what? Collate all the d, cos, and the sine function at the right hand side. I want sine 4x to appear once at the left hand side, and equally I want cos 4x to appear once. So all I need to do, I will collate all the sines and equally collate all the cos. So for sine, I have this 1, 2, then 3. Each of them, they are all 3, 3. So I underline the case of sine. So we can collate them by taking the positive first, followed by the negative. So for the positive, I have 20. And equally, while we are doing that, we know that we have 3 sines. Now d appeared twice. We have minus 16d and plus 16d. Here we have 20c minus 10d sine 4x. Then plus, we'll come to that of cos. We have this guy as negative c. We have this guy as positive c. Then we have this guy as negative d. So we can add the two c's together. So negative 16c plus positive 6c would have given us positive negative 10c. Therefore, this would have given us minus 10c minus 20d cos 4x is equal to 2 sine 4x. This is it. At this point, now that we have successfully, let me underline this place now, let me go to this place. Now that we have successfully collate this expression where we have one sign at the left hand side, one cos at the left hand side, then we can simplify this expression. Now, all we just need to do is to compare both sides. Like I explained before, for you to find numbers of unknown in one equation, you only make use of comparison methods. And to do that, we will compare sine 4x, then cos 4x. Alright. Now, for sine 4x, at the left hand side, we have 20c minus 10d. And at the right hand side, understand that we are only picking the coefficient. Now we already have sine 4x here, so we only need the coefficient of sine 4x, and that's exactly what we have here at the left hand side. When we come to the right hand side, if you remove sine 4x here, we have 2. We call this equation A. Now for the cos 4x at the left hand side, we have minus 10d minus 10c, then minus 20d is equal to what? When we look at the right hand side of this equation, there is no cos function. That means cos is equal to 0. So we do not have it. So in another way, you can try to put here as 0 cos 4s. By extension, if you want to extend it, since we do not have cos, then you can introduce. So the coefficient of cos 4x, of course, anything multiplied by 0 is 0, is still assuming that this is not existing, right? So the coefficient of cos 4x is 0 if you decide to put it this way. Now from here, from equation A and B, you can solve this simultaneously, alright? But it is easier to use elimination, substitution, or any method of your choice. You can use any method, but let's use substitution. So from equation B, we have that 10c is equal to minus 20d. From here we have c is equal to minus 20d over 10, and this will have given us minus 2d. We call this equation C. Now when we put minus 2d into equation A in place of C, we will be able to obtain d. So we'll come to equation A and substitute equation C into equation A. Now at this point, substitute equation C into equation A. We're going to have 20 multiplied by minus 2d, then minus 10d is equal to 2. So from here, what do? All I need to do is to multiply, and this will have given us minus 40d minus 10d is equal to 2, and this will give us minus 50d is equal to 2. Don't forget, minus 40d minus 10d would have given us minus 50d, and d would have given us 2 over minus 50, and this would have given us minus 1 over 25. Now we have gotten the value of d. If the value of d is obtained, then we can find the value of c. What is c? C. Okay? Value of c. C would have been equal to what? Minus 2d. And what is d? C would have been minus 2 multiplied by 1 over 25. And c would have been equal to what? Positive 2 over 25. This is it. So we have successfully obtained the value for d and c. All we need to do now is to come to this equation and substitute for c and equally substitute for d. That's all. So we wipe this place here. At this point, we record that the particular integral is equal to c cos 4x plus d sine 4x. And c is 2 over 25 cos 4x, and d is minus 1 over 25 d sine 4x. This is the particular integral we just obtained. So the final solution would have given us complementary function plus particular integral, which we define as our equation 1 as usual. And now, what is the complementary function? We know that the complementary function is what we have here. Then we have a exponent 2x plus b exponent 3x plus 1 over 25, open bracket, 2 cos 4x minus sine 4x. This is the answer to this. When you multiply out together, just factorize out 1 over 25. This is the answer to this very question. In fact, this aspect is very, very deep. So you see that when you memorize the steps, you will forget. But when you understand the principles, you will not forget. And that's the reason why when you understand principles, you suddenly become a principal. And when you understand boundary conditions, you will not overstep your boundary. So seek to understand principles, no matter how lengthy they prove to be, you will be able to solve them effectively and even meet up with time when you know the principle. So guys, don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell for more exciting videos. Don't forget, we will quickly look at the question number 10, which will serve as the second example under this case of second order differential equation when f of x is equal to trigonometrical function. So question number 10 on the board, and we are asked to solve d squared y over dx squared plus 4dy over dx plus 4y is equal to 2 cos 2x. The first one we solved was 2 sin 4x. Now this is now cos, and this is also part of the trigonometrical functions. Now we understand that in as much as the right hand side of this equation is not equal to 0 or is equal to any other function, we have two results here, which is the complementary function and the particular integral. So we put that our general solution as complementary function plus particular integral. We'll label this as equation 1. So the next thing we are quickly going to do is to obtain the complementary function. And to find the complementary function, all we simply do is to equate the right hand side of the given equation to 0. Therefore, we simply say to find the C function, let the right hand side of the given equation be equal to 0. So we are going to replace 2 cos 2x with 0. Now we have this as d squared y over the x squared plus 4dy over dx plus 4y is equal to 0. We can label this as equation 2. And now from equation 2, now that we have successfully equated the given equation to 0, we can obtain the equivalent auxiliary equation. And the auxiliary equation here becomes m squared plus 4m plus 4 multiplied by 1, which is 4, equal to 0. This is equation 3, which is the auxiliary equation. Now from the auxiliary equation, we can equally obtain the roots of the equation by solving this equation quadratically. Alright? Now to have this done, all we do is to use factorization method. This guy multiplied by this guy would have given us plus 4m squared. And the two factors of 4 that will give us 4 is either 4 multiplied by 1 or 2 multiplied by 2. Now 2 plus 2 will give us 4. That means we have to go with 2 multiplied by 2. But if we go with 4 multiplied by 4, 4 multiplied by 1, which will give us 4, when we add them together, it will give us 5. And at the middle here, we do not have 5. That's exactly why we are going for 2 multiplied by 2 to give us 4. And when we add them together, it would have given us plus 4. Then we have this as m squared plus 4m, 2m, plus another 2m plus 4 is equal to 0. Now between the first two terms, we have m to be common, so we have m open bracket, 2m squared divided by m, we have m, plus 2m divided by m, we have 2. What is common here is 2, and we also have m plus 2. This is it, equal to 0. And we understand that at this point now, all we need to do is to collate this fraction. And for us to collate this bracket, we put down the multiplication factors to form one bracket, and now pick one of the equal brackets. And as we understand this, we know that for the product of two factors to be 0, one of the factors must exactly be 0. Then we have m plus 2 is equal to 0, or m plus 2 is equal to 0. From here we have m is equal to 2. Now when we collect like term, we then have that m is equal to minus 2 or minus 2. Now we have roots but equal value. That is to say, m is equal to 2 minus 2 twice. And when we have this, what is the equivalent complementary function? We understand that the equivalent complementary function C f is given as y, which is equal to a, which is equivalent to what? Exponential mx into a plus bx. And finally, we have exponential minus 2x into a plus bx. We have successfully obtained the complementary function. Now the next thing we are quickly going to do is to equally obtain the particular integral following the usual process. Now we know that to find P.I, P.I is equal to y, which is equal to dc cos. Now, what's the angle here? Is 2x. Alright, so 2x plus d sine 2x. Now, when we differentiate this function, we have d over dx is equal to, like I explained before, if you differentiate strict function, all you need to do is differentiate the angle. So the angle here is 2x. If we differentiate 2x, we have 2. And that will multiply this coefficient. We're going to have 2c. When we now differentiate cos, we have negative sign. Then we put the negative here, put sign here, then repeat the angle. Then plus, when we do the same here, the 2 will come out, we have 2d. And when we differentiate sign, we have positive cos, 2x. Now we have differentiated the first time, we will differentiate the second time, this square y over the s squared. Now when we differentiate this equation, these 2 will also come out again. Because when we differentiate 2s, we have 2 multiplied by the existing negative 2, then we have negative 4. And when we differentiate sign, we have positive cos, so it does not affect the answer then. But this will have turned to negative 4 d sine 2s. When we equally differentiate 2x, we have 2. 2 multiplied by 2 is 4. But when we differentiate cos, we have negative sign. That's why we now have the negative here. All we need to do now is to substitute this guy, and this guy into the given equation. When we do that, then we will be able to obtain the value of c and d. Then we can come here, substitute the value of c here and that of d here. We are done. Now let's get to work. So at this point, we replace this guy with minus 4 c cos 2x minus 4 d sine 2x. We are done with the first term, then plus 4 into minus 2 sine minus 2c sine 2x plus 2d cos 2x, then plus 4. The value of y is c cos 2x plus d sine 2x, all equal to 2 cos 2x. Okay? Yeah, 2 cos 2x. This is it. Very, very lengthy. Now, at this point, all we need to do is to, this will give us negative 4c cos 2x, negative 4d sine 2x. 2 multiplied by negative 2, we have this to be negative 8c sine 2x, and this multiplied by this, you have positive 8d cos 2x. This guy multiplied by this, you have 4c cos 2x. Then 4 multiplied by d, you have plus 4d sine 2x is equal to 2 cos 2x. Now, we are progressing. At this point, the next thing we will do here is to identify the sine function. This guy is sine, this guy is sine, and this guy here is sine, all at the left-hand side. So we need only one sine to appear, and we need only one cos to appear. Now that we have 2 unknowns, and we have 3 terms here, that means 1 must be common. So this one is d, this one is equally d. So now, minus 4d plus 4d would have given us 0. So it shows that this guy cancels this guy. Are you there? Then we are left with just minus 8 sine. Now I have minus 8c sine 2x. That's what we are left with. Then for cos, this is minus 4 cos 2x, and this is plus 4 cos 2x. See, this guy will also cancel this guy. And if this guy eliminates this guy, we have plus 8d cos 2x. And this is equivalent to 2 cos 2x. At this point, we can divide the board into 2 equal parts. All we need to do now that we have successfully reduced this to have one sine function at the left, one cos function at the left, and at the right now, we only have cos function. So I can introduce sine, which is 0 sine 2x, so that I can compare both sides. Now, for me to compare both sides now, I will come with sine functions, sine 2x. Why are we doing this? Because we have two unknowns in one equation. And to be able to obtain two values for two unknowns in one equation, we must use comparison method. So, why this become cos 2x? Now, for this guy, at the left hand side, the coefficient of sine 2x is just minus 8c. While at the right hand side, the coefficient of sine 2x is 0. Just check it. Sine at the right hand side is 0. That's the coefficient. It does not exist. Then for cos, we have 8d is equal to the coefficient at the other side is 2. That's it. So we can call this equation A, as usual we call this equation B. Now from equation A, we know that C is equal to 0 divided by negative 8. And this will have given us 0. And then D, from equation B, D would have given us what? 2 over 8, and this will give us 1 over 4. That our particular integral is equal to C cos 2x plus D sine 2x. Then we have particular integral is equal to, what is C? C is 0, so you can put in 0 multiplied by cos 2x plus D is 1 over 4. So we have 1 over 4 multiplied by what? Sine 2x. And finally, our particular integral would have given us 1 over 4 sine 2x. Finally, we record that general solution y is equal to complementary function plus particular integral. Now we already obtained the complementary function, we also have the particular integral. So, what is our complementary function? Our complementary function is a exponent 2x, open bracket a plus bx, plus 1 over 4 sine 2x. This is the answer to this very question. So guys, this thing is very simple, very simple. All you just need to do is to understand the principles. When you understand the principles, you suddenly become a principal. And when you understand boundary conditions, guys, you will not overstep your boundaries. Guys, I wish you all the best. Don't forget to subscribe to this YouTube channel if you have not done so, and please ensure that you turn on the post notification bell for more exciting videos when uploaded. Please guys, share this video, like this video, and make your necessary comment. We love you guys. We will see you in the next class. Thanks for watching Master Builders Academy. We love you guys.